This is a question about solving non-homogeneous differential equation by the method of undetermined coefficients. So let's start to work on this one. First, you have to find the solution to the characteristic equation. And I got this one by completing the square, but you can use quadratic formula. Well, whatever method you use, you just get this solution. And once you get this solution, you can write down the general, not the general solution, but the solution corresponding to this characteristic value, which is negative 2 comes here, and this is 1 times I, so it's cosine 1x and sine 1x, okay? And we call this a complementary solution, and this is not really a solution to the original equation, but the one with the right side being 0, okay? So this is the solution of the homogeneous differential equation, where y double prime plus 4y prime plus 5y equals to 0. Okay. Now, you want to get this first because you want to check for duplication. When you try to use the method of undetermined coefficients, to create x, you need x and its derivative, which is 1, so you need ax plus b. And then e to the negative x differentiates to e to the negative x times something. So to create e to the negative x, you just need e to the negative x. Okay, so to create this, you just need this. Okay. Now, when you write your form of the particular solution via the method of undetermined coefficients, it's important to check whether any of your terms are duplicated in the complementary solution. If it is, then the corresponding terms must be multiplied by x. But here you can see that, say, this is really two functions, e to the negative 2x times cosine x and e to the negative 2x times sine x. Both of them are linearly independent with e to the negative x, so and these are totally different functions, so you can easily see that there's no duplication. And if there's no duplication, there's nothing to multiply by x, so it's easier. Okay. All right, so now let's try to find the specific values of a, b, and c that will satisfy this differential equation. To do so, you really just have to plug into the left side. That means I need to know what y prime is, so let's differentiate this once. Ax differentiates to a, b differentiates to 0, e to the negative x by the chain rule. It's negative of c e to the negative x, okay? And then you differentiate this again to get the second derivative, and another negative one comes down by the chain rule to make this as positive, and a is a constant, so it goes away. So we have this, we plugged into the left side, so c e to the negative x is replacing y double prime, and a minus c e to the negative x is replacing y prime, and so on and so on. And if you do that, you now have to make sure that these two sides agree as functions. That means we have to be able to compare, and to compare, it's important to rewrite the left side to look like the right side. So I see that the only x term is right here, so I write 5ax right here. And then 4a, 5b, these are the constant terms, so I write it here. And then you also have c, negative 4c, and plus 5c times e to the negative x. So I write it like this. And now that the two sides must equal as functions, 5a must equal to 5. 4a plus 5b is the constant term, but there's no constant term here. So 4a plus 5b should be 0. And this, if you simplify, this is just 2c, and 2c should equal to 3. And therefore, we get the following system of equations, which is pretty easy to solve, because if you divide by 5, you get a equals to 1. Plug into the next one, you get 4 times 1 plus 5b equals to 0. This 4, you move it to the other side, you get 5b equals to negative 4, and divide both sides by 5, and you get b equals to negative 4 over 5. And then 2c is 3, so c is 3 over 2. Once you get these solutions, now you can plug them back into your yp, and you found the particular solution. Okay, these are plugged into here. And that's pretty much it. Now all you have to do is to combine them. Y is equal to the complementary solution plus the particular solution. And I don't know why I wrote this down. Y is complementary plus particular, and that's equal to these two added together. Now, once you have this, then you have to plug this into your web work if you're solving the web work problem. And I just wrote explicitly how you should write these things for this part because it's a little confusing. You have to use C1 and C2. But basically, this is exactly what this is doing, okay? And that's it. That's your answer.